Hi there, welcome back. Well, we've got this thing on its back, and you can probably guess what it's for. Let me start by saying that sometimes you do get lucky in this hobby, and I got lucky. I found a restoration, a report in German for the Braun SK 25, which is a later version of this radio, and I thought that would be worthless because the 25 actually uses an ECH 81, so it's a more conventional mixer oscillator, and I thought it'd be totally useless. But what I didn't expect was to find a service manual for the SK2-2 or SK2/2 and the SK22, and they apologize that it is slightly different to the SK25. Well, no apology needed, because that's exactly what I wanted. And I've actually translated the alignment part of that instruction. So I've been able to determine that the IF coils here, or which IF coils here, correspond to which, to whether it's AM or FM. And I'm going to start with the AM because I want to see if somebody's fiddled at the top. And I have a feeling someone has, because one of the actual cores is pretty near the surface. Now, it's just probably wishful thinking on my part, but we'll find out soon enough. What I've got here is a signal coming in. It's a 460 kilohertz signal carrier. That's the IF frequency for AM, or the medium wave in this case. It's modulated, and the frequency 460 amplitude is the minimum that will go on this signal generator. And then I've got it going through another, what is it, 612. I've actually got 18 dBs of attenuation, which probably is a bit too much, but we'll see. And now I've got this thing connected to the dummy load selector there. I can put speaker on and I can actually hear it, or dummy. It is an 8 ohm dummy in this case, which is slightly higher than what they say on the instructions. They say 5 ohms, but that's fine. I can put it on 4. That's also fine. I'm just doing the alignment, not testing the AF. But I do know which ones to adjust, and we're going to see whether we get any improvement. So let me focus on the scope. And what I'm going to do is, I've got the alignment tool. I've actually got a proper one this time, because this is a very fine core in there. And I have to adjust the two cores that are further into the radio, not the ones on the edges. The ones towards the edges, on the outside as it were, they are the FM. So I'm only going to touch that one, and the corresponding ones at the top. And we'll see if that makes any difference. Okay, I've got the volume on max. Pretty small signal there, 9700 millivolts RMS approximately coming out of there. Let me just check the frequency. It is 460, and the modulation is AM. Yes, the audio signal I want to hear is 600 hertz, and I've got 30% modulation. So let's see what happens when we adjust these cores. I'm actually going to start with the bottom ones, because I'm on this side. These things have not got any wax in them, which makes them easier to, well, sort of easier. Not really that much easier. I think I've got it now. And that's going down. What did I have, 90 something? Damn it, it slipped again. I'm feeding the signal, by the way, as it says in the instructions, into the first grid of the EF89. This thing has slipped. I haven't got it yet. Why is it going down? That's the volume. That there seems to be the peak on the bottom one. Let's try the top one. Not much change there. So I guess nobody messed with that. Oh yeah. Okay, that's gone up nicely. There's our peak. Let me try the other top one. Usually on these things, when people play around with them, they usually mess with the top ones because those are the ones that are accessible. It's going down. Oh, that's going up nicely. Bloody hell. What have they done here? Okay, that's a peak. Oh, that's nice. Let me try the bottom one on the other one. This tool was not grabbing too well. Try my wooden one again. Nope. I've got to reduce that signal size, so I'm going to put in 24 dB of attenuation. I think I've got it. There's the peak. That's a peak. Let's go to the other side again. That's about the peak. Let me go to the first one again. That seems to be it. Back to the underside. That seems to be it. And that is about all we need to do. I think we've aligned the AM. The IF anyway. Oh, that was pretty simple. I'm not going to mess around with the IF trap because that thing is waxed and the wax is still there and those things very, very seldom go off. So I'm going to try the AM. Let's turn this guy around and see what we get. Okay, I've got my dummy load antenna in there. I've actually just got the signal line going in. I don't know whether I should put the ground to the other side of the dipole. I don't think so, but let's try it like this. See what we get. It's on AM. I've soldered the speaker back in there. See if we get lucky. Whoa, bloody hell. That is noisy. Let me try this. No. But I should actually, this is actually the ground signal. I'm going to try ground. Ha! Brilliant. This has got a 3-to-1 reduction here, but with the big dial, it obviously becomes easier to tune in. That's the Portuguese, the Madeiran AM medium wave station. Canary Islands.
SK3 para Gerard Piqué. Melo.
Recuerdo, Manolo, lo que pone el VAR para el tema de...
Esas áreas que normalmente más preocupan a los padres, que son el aprendizaje, las acciones y la conducta.
Buscando a Frenkie de Jong. Leo Messi, que por cierto lleva 5 partidos consecutivos.
Okay. Now that's more like it. That is definitely more like it. The only thing that's weird is I always use my mini whip antenna on AM, but obviously I normally have a ground and antenna input. In this case, the AM antenna is actually onto the dipole of the FM. So I decided just to connect the negative or the ground of the mini whip to the chassis, and that's why we got the quietening down. Now this is very, very good reception. This is early afternoon in Madeira. Usually you don't get much more than this. In fact, you usually get a lot less than this. But this here is the Canary Islands. Try the tone control.
Indica que vayan arriba, que lo va a colocar ahí en el interior del área. No, al final prefiere dejar atrás para Gerard Piqué. Ahora sí están todos metidos en terreno de Levante, excepción de Marc-André ter Stegen.
Good stuff.
Desplazamiento en diagonal de Gerard Piqué para Nelson Semedo, se queda corto. Ha cortado.
O sea que estamos con excesivas frecuencias.
¡Punto es! ¡Le va por transit!
Para el ocio.
This is North Africa somewhere. This is the Madeiran station. There's only one in Madeira, in AM. So yeah, I'm happy. Let's just see. Obviously done nothing to FM, and I'm using the mini whip, so. Not much, but we don't normally get much with the mini whip anyway. But, since it's obvious somebody messed with those two at the top there, because, as I said, one of them looked like it was almost coming out. It was pretty far out. So, this is obviously what was accessible, and as usual, somebody messed with it. That's so normal. If something goes wrong with the radio, they see screws and they want to tamper with them. But it also makes for an easy alignment, and it's always so satisfying when you see this thing increase dramatically. It's fantastic. And so I think the tube's actually fine. I think if they messed with those two, they would have messed with the other two. I mean, I only found out which ones were AM now. The one thing that worries me is one of these at the back, which are FM, one of them is the ratio detector nulling coil. And that one you got to do with a different technique, and I'm not sure which one it is. I mean, the instructions obviously give it, but I'll do the FM one next. So that's good. AM is aligned. At least the IF is aligned. Brilliant. Well, let's start the FM alignment. As usual, we set this to the FM IF frequency, 10.7 megahertz. I've got 10 millivolts RMS output there. It's unmodulated, and I activate it. I connect it to the signal to that tube shield that's been desoldered from the ground, and the ground terminal from the signal goes to the ground itself. Now I'm going to measure the voltage across the ratio detector capacitor there, which is that electrolytic. I would probably be better off doing it with an analog multimeter, but the one I've got is a low input impedance. I've got a FET multimeter that I'm still restoring. So for now I'm going to do it with the digital multimeter with Big Brother here. And now I look at the instructions and it tells me to set this to FM, which it is on FM, and desolder the shield. I've done that. And I'm supposed to set this tuning around 90, which is about halfway through, Because I don't have the faceplate here, I don't exactly know where it is, but I'll put it approximately halfway, and then I'm supposed to feed that signal in to the shield, in other words, to loosely couple it to the ECC85. And what I should get there is a negative DC voltage, the strength of which depends on how well aligned the IF transformers are. And they tell you to align, to adjust coils Y dash, V dash, U dash, S dash, T dash. In other words, the two IF transformers, with the exception of, let's see, it's the coils nearest the edge, so it's the bottom one in this case. The top one's the one closest to the inside of the radio with the AM ones. So now I'm doing the FM ones. And the one that I mustn't mess with is, let's see, Y dash, where's Y dash? That's the bottom one. V dash is the bottom one. U dash is the first top one. So I must leave the second top one alone for now. And I must also do S and T, which are these guys on the side here. If you can see that, that's the IF transformer, or the two coupled coils inside the FM can. And I must do that for the highest DC voltage on here. So switch that on. I don't really need volume because this is not measuring AF at all. It's just measuring that DC voltage. And see what happens. Might as well try and get some noise. We've got some noise. Now, it did say set this to the 10 volt range. So they're probably expecting you to get somewhere around, let's say, half of that, which is what we do have. And I'm going to start from the last one. In other words, I'm going to start from this one over here. That's the last one before the audio section. See if I can improve that at all. Maybe it is. Oh, it's going down. It's going up. 4.55, that seems to be the peak. Okay, I'll do this one now. That's going down. That seems to be about the peak. Not much difference there. Let's see about the top one. Now, the thing to do is to make sure you think of this as relative, because the coupling at the top is not absolute. That's going down. Whoa. Yep. That's going up a hell of a lot. In fact, so much so that I'm going to drop the amplitude of the input signal to about 5 millivolts. Half of that. Somebody really messed with this. Jesus crikey. Make that smaller. 2 millivolts. Okay, I think I've hit a peak. Yep. That's my peak over there. That was one hell of a difference. Again, proof that somebody did mess with that top one. Just checking the bottom one again. No, that's peaked. Okay, let me try the side ones here. Whoa, somebody messed with that as well? It's impossible. Why would they do that? This thing's on the inside. Yeah. Now the thing is stuck in there. That's about the peak over there somewhere. That was quite a difference. Just checking the other one again. Getting a bit more out of it. Yeah. Back to the other one. Those are the S and T's. I think that's about it. That is a pretty dramatic change. Bloody hell. Okay, next step. They tell you to take two resistors. They say 50k ohm each. I use 100 kilo ohms in series, and I clip them across that ratio detector capacitor. And then you're supposed to measure in the very small range, 10 microamp range, and null out. Let me set that up. I've gone and changed this somewhat. I've got my 10.7 megahertz signal coming in here. I'm going to modulate it with an FM signal. 50 kilohertz deviation is fine, 600 hertz. Shape sine wave, okay. And I'm feeding that in, and I'm going to look at that sine wave, demodulate it on the scope, and adjust that for the best sine wave possible. Let's hear it first. Yep, we can hear it. Shouldn't make any difference there. We can hear it, we should be able to see it on the scope. Looks pretty crappy right now. Okay, let me show you. It's certainly starting to look better. Now I've got this on speaker. I actually want to make it slightly bigger sine wave to get a really good sine wave over here. Because that's not what I'm getting at the moment. Ah, that's better. See, it's actually found a second peak. There's that first one. I'm changing the speaker volume because I don't want to blow my ears out. There's the best position. That's it. Now that I've got that nulled out in the general vicinity, and if I go here to this last one again, put this on, what is it, whoa, 10 microamps. I can, if I had a zero null meter, in other words, if the middle was 0, it would be slightly to the left. But this has got a reverse DC polarity thing here. So I can see that I'm slightly to the one side. Oh, you see that? Now I can go down to 0 and it's going up the other side because I reversed the polarity when it went through 0, right? Watch this. Reverse polarity. Keep turning. So what I want to do is leave it on right on 0. Damn, it's sensitive. There we go. That's it. And my FM is aligned. Perfect. I'll have to solder that tag again when I'm finished. I'm going to put all that off, put in the dipole antenna and see if we've improved. I sure hope we have. Bloody hell, we sure have. Never find talk radio when you want it. Don't want to leave music on there, you get hit with copyright. This is one of the more distant stations, but
Please, could you find
okay, I think that's done. So in summary, what exactly had happened? Well, somebody went nuts with these guys, all of them. And that's why our reception was very weak. Now, when we detected that reception was weak on both FM and AM, it could have been one of the tubes in this particular line. It could even be the ECC85, which in this case acts in both the FM and the AM. But having found that the AM improved dramatically, the IF alignment improved dramatically when playing with these guys, and especially because it was the top ones, that kind of gave us a hint that somebody had messed with these guys here. It's irresistible. What I can't understand is why someone would mess with these two on the side. These guys over here are the first coupling on the output of the FM signal from the FM front end. And this, one of them at least, made a dramatic change. So I think somebody just came in here and went crazy. But that's good news because it means all the components are fine. It's just the alignment. I am actually doing a restoration of a Nordmende 3366 FET voltometer, which a friend of mine got for me in Germany, and I've tested it. It needs a little bit of work, but ideally that's what I would use in doing this nulling out, because it's got a center zero position. So you set it on center zero and then you can see it going both up and down until you get it perfectly centered. The other way to do that is you want a perfect sine wave, perfect signal coming out. And the way to do that is to adjust it by looking at that signal on the scope. And that's the one I've just used here. So next step, I want to just have a quick look on the schematic at how this whole FM AM works with regard to this front end tube over here, because this is rather unusual. Usually they use the ECC85 is just for the FM front end, and then you've got an ECH 81 on the front end, and that does the mixer and oscillator section for the AM and acts just as a FM RF amplifier, really, in the front end. So this is different, and I want to have a look at that. I think it's pretty interesting what they've done there. They get this tube to do two roles, to play two roles, the first triode, depending on whether you've selected AM or FM. So it might be interesting to look at that. I'm not claiming to have the absolute correct interpretation of the circuit, but I think I've got it down to knowing how it works, and I'll try and explain that, and perhaps anybody out there who sees the gaping holes in my explanation can come back and explain that to us in the comments. All right, let's get on with it. This is the full schematic, and I've done quite a bit of research on the web trying to find out what makes this particular setup different to the normal ones, because I know it is different. And it's different in that, contrary to what usually happens with FM and AM sets, this thing doesn't have an ECH 81 down here. The normal sets have an ECH 81 here. They have the ECC 85 here for the FM in the FM front end. This one is different in that it is actually putting this tube to work both for FM and AM. And the way it's done is very, very clever. I find it amazing, and I'm fascinated by the thought process that went into creating this. It's all very well to analyze it and try and figure out how it works. I really admire the brains behind actually getting this thing done in the first place. And this is what makes this hobby so fascinating. There's always something new to learn, and if there wasn't, I would have stopped the hobby, I would have stopped the channel. I'm a sucker for new knowledge, as a lot of you are, I know. So I did a lot of research, and I didn't actually find a good explanation on something like this. I'm sure there's something out there, but I haven't found it. So I went through this, and I wanted to break this down to modules that I could understand. I've done this before, especially when there's a lot of switching involved. What I do is I select a position, a switch position. In this case, the switch is the band switch. And then I try to eliminate all the circuitry that's taken out of function by that selection. And you'll see how I do that in a minute. It's very simple here because we've got one selector switch, and this switch has four parts where it comes into the circuit. One of them is over here, one of them is over here, the other one is here, and the other one is there. Now, the way it's drawn at the moment is with FM selected, and the first thing I want to do is I want to put in the B+ lines to these tubes, to this front end tube here that's got the two triodes over there, to that one and that one. These are the tubes that are really involved in the at least the front ends of the radio reception. So if I bring in the B+, this is what I have. B+ comes from here, from the second capacitor. It feeds the anodes of the two anodes of that tube. It simultaneously feeds the two anodes and the screen grid of those two tubes, as you can see here. What you do see also is that at no point do any of these switching positions affect the flow of B+. So whether you have this thing set to AM or FM, all the tubes on this front section have B+, so they're operational. In some sets, when you select FM, the B+ to the oscillator section of the ECH 81 is removed. And in other cases, when you select AM, the full B+ to the ECC 85 is removed, and obviously that can have some implications with the heater voltages being there without B+, but that's a different story. In this case, the tubes are always powered, regardless of what band you've selected. So the next step is to take the selection of U, which is FM, over there, over there, over there, and over there, and remove the parts of the circuitry that are cancelled out. And I'll give you an example. If we look at this part of the circuit, as it is for FM, what you have is a resistor coming down here to this coil, to a tapping of this coil, and then it goes through that side of the tapping to ground. It then goes through this side of that tapping of that coil to the capacitor, but that capacitor is also connected to ground. So effectively this capacitor is nulled out because both sides are connected to ground. It's grounded on both sides, so you could bring ground to here. In fact, you can go one step further, because at this point, if that capacitor is grounded, that side's grounded, that side's grounded, all you have is very small resistors to ground on these ends, which are probably close to zero, so you can bring ground to there. In fact, you can bring ground to here. And that's exactly what we do when we eliminate parts of the circuit that don't come into the equation. Also, what is that doing there? If that's connected to ground, that's floating, that's floating, that's floating, that's floating. So you can actually eliminate that completely. And I'm going to just flip back and show you just what happens when you do that to the whole front end of the radio. That's what happens. And when that happens, this thing starts looking a hell of a lot simpler. Now we've got FM selected. And what we have here is a pretty normal FM front end. This triode is actually just amplifying the front end, the FM tuned signal, or the FM signal coming in. It'll be coming in at, well, the bands, so the middle of the band is about 90, I think it's 90 megahertz, because this is 88 to 100 if I'm not mistaken. So that's where you are, in the middle there somewhere, and that's all getting amplified by this triode with a normal triode amplifier. There's your grid resistor to ground, because the ground is now moved up here. It's a 200 ohm resistor that biases that triode. And your signal then comes out the top here. It goes, it's fed by the B+, it goes through that transformer, that coil there. It induces on this side. That's a tuned circuit. So you basically tune in the front end frequency that you want with one part of C9. That's the FM, one part of the FM condenser. So you're tuning the front end. The other half of that FM condenser is over here. That's tuning an oscillator here. And then that goes into the tube. And this whole thing does the, it's an oscillator mixer, which then brings out your signal at the IF frequency, which is fed through that IF transformer, that first coupling inside the FM can. That comes out there, goes down here. And when it goes down here, it goes into the grid of that tube there, the F89. And that basically just amplifies it. It's an IF amplifier in this case. And that signal is amplified and gets fed through that coil, that transformer. That's the IF transformer. The top part is the FM section. And that gets passed on to the next grid, and then that gets passed on to the final part of the circuit. So pretty normal FM front end. And nothing else is here to complicate it, because I've taken away the AM part of the circuit. Now let's do this for the AM section. So what we're now going to do is we're going to eliminate as much of the circuitry as possible at this front end that have to do just with the FM and leave the AM portions on. So here goes. That's what it looks like. Now this starts looking pretty simple. If we focus on this part of the circuit, what we have is the AM antenna in here. There's that first coil that sends a signal through, and it meets a tank circuit. This is the tank circuit. There's your front end tuning. That's the one half of the tuning condenser for the AM. And so your AM, pre-tuned AM or pre-selected AM signal goes into the grid of that tube. Now where's the mixer? Well, usually when you see an ECH81, the oscillator section is somewhere down here. There is no oscillator here. The oscillator signal is coming into pin 9, or we suspect it is, and we follow that through to here and up. And we find this. Now what is this? Well, we've got another tuned circuit over here. This tuned circuit has the other half of the AM condenser with a coil that has a center tap, or has a tapping. We don't know if it's a center tap. This is a tuned tank circuit, and this signal is fed or feeds through here into there, into the grid. And that means that because the way this is configured, that signal will be reflected down here. This would probably be a gain of 0.999 or whatever, right? Cathode follower is the way I understand it anyway. That signal then comes through here, back into there, into that tapping of that tank circuit, of that coil, and that signal is trying to find ground. So it induces a field on this part of the coil, but obviously if it induces it on that part of the coil, it induces on the entire coil, and this is acting almost like an autotransformer. So the same signal is amplified in effect to this point here, which is where your oscillator signal comes out. And then it feeds back in through there into the grid. So you've got a positive feedback here. This is a positive feedback, and the positive feedback is essential for maintaining oscillation in a tuned circuit, basically an oscillator. Now, I did quite a bit of searching, and I came up with something interesting. This circuit here. This circuit I took from the website Electronics and More on LC circuits in radio, and this is called a Hartley Oscillator. And the way this works is you've got your B plus coming in here, you've got a small filter cap down there, it feeds the anode of the triode. The cathode signal comes out through a tank circuit, has a tuned tank circuit here, usually tuned with a variable capacitor here. It creates an effect, basically a autotransformer effect on here, which then takes this signal, creates a signal up here. That signal goes through a grid resistor, grid capacitor, back into your grid, and this whole thing just keeps basically in a feedback loop producing an oscillator signal, the frequency of which you adjust with either the cap or the coil, but usually the capacitor. And if we look at this here, that's what we've got really. We've got B plus coming in here. We've got a little filter to ground. That feeds the anode, just like there. Then your cathode comes out, and it's actually meeting a resistor here. Here it doesn't meet a resistor, but it goes straight to the tapping of that coil. This resistor can be considered fairly small, and it comes into the tapping of that coil to ground, creates an autotransformer effect. This is the tank circuit, which is oscillating at the frequency set between the coil inductance and the capacitor, the tuned capacitor, and the signal is then produced there, which is then fed back through there, and you've got yourself a resistance capacitance here as well, which is going to basically emulate that grid capacitor. There are a few components here that I haven't taken out because I'm not sure if they are effective at the low frequencies that we're talking about. Remember, this thing works on two limits of frequency, two levels of frequency. When it's working as an FM front-end amplifier, it's amplifying, 88 to 110 or 100 megahertz. When it's working as an AM oscillator, it's oscillating to a maximum of about 2.2 megahertz, because the highest frequency you get coming in the front end will be, I think it's 1.6 for medium wave, plus 460 IF frequency, so 2.1 megahertz, say. At 2.1 megahertz, some of these components behave completely differently to how they would at 100 megahertz. In other words, some of them actually disappear and some of them become crucial. Now, the frequency you're producing here is the frequency, the oscillator frequency, that is equal to the front end frequency plus the 460 kilohertz IF frequency. So that's basically what I believe we have here. It's not exact representation of this Hartley oscillator, but I think that's the way this thing is working. And if we go down here now, we've got the oscillator frequency coming in here, the front end frequency coming in here. This thing does the mixing. The frequencies that should come out here would be that one, their sum and their difference. Because of the tuning of the IF transformer here, you basically cut out all the ones except the difference, which is the 460 kilohertz modulated with your audio. That's the one that you pass through into this IF amplifier stage, which then passes through back through this IF transformer, and that's the one that gets decoded. So basically this thing has been made to work to play two roles depending on how you select your band switch. And the reason you can do this with this particular radio is because it's a single AM frequency and a single FM frequency. So you don't have multiple tunings necessary here to change different, you'd have to do that there as well, for different bands. You've got one band, it's medium wave. So it becomes quite easy to make this work on the AM as well, because you don't have to really have various AM oscillator bands, oscillator frequency bands. And I think it's brilliant. I think it's really brilliant. I take my hat off to the guys who came up with this. As I said, it's one thing to analyze it, and even then you sometimes get it wrong. I might have it completely wrong here, for all I know. But it's a different story when you have to come up with this originally, and I really take my hat off to the guys who did that. Now, as I've said before many times, I don't profess to be an expert on tubes. When I finished university in '85, tubes were long gone. I mean, we didn't touch the stuff. Mostly it was digits, digital circuits, some analog, but mostly digital. So what I know about tubes I've taught myself. Fortunately, I had the vocabulary that I learned at university in the field of electronics, which does certainly help you to understand other applications of it. And there are a lot of people out there, a lot of subscribers, some of my subscribers who are a hell of a lot better at tube theory, tube circuit theory than I am. So I invite you to participate in the comments, give us your opinion, give me your corrections / criticisms if that's the case, and maybe we can really understand how this thing works a lot better than the way I've just explained it now. So this is brilliant. This is why I do the hobby. Learn something new, completely new. I love it. So if you've enjoyed this, please like, subscribe, check that bell thingy on the subscribe button so you get notified of new videos, and share. And if you want to support the channel, you can do so on Patreon. The link is at the end of the video. I'm going to be back with the final video where I do the cabinet. I've got to paint that. It's a tedious bit of work, but I'll do that, and I'll present the final result with the final testing in a shorter video in the very near future. Thanks for watching. Bye for now.